The properties of limits. 1. Limit of a constant. Limit of c equals c as x approaches to a. Example. Limit of 3 is equal to 3 as x approaches to 2. Limit of 3 is equal to 3 as x approaches to 4. Limit of 5 is equal to 5 as x approaches to 0. So it means whatever the value of constant, the answer will be the constant irregardless of the value of x. 2. Limit obtained by direct substitution. Limit of f of x is equal to f of a as x approaches to a. In finding the value of a given expression, the first step usually done is by substituting the value of a. If the computed value is defined, then that is the limit. If not, then other property may be tried. Example. Limit of 2x cubed minus x plus 5 as x approaches to negative 2. Substituting the value of x, which is equal to minus 2, we will have 2 multiplied by negative 2 cubed minus negative 2 plus 5. By performing mathematical operation, we will have 2 multiplied by negative 8 plus 2 plus 5. Negative 16 plus 2 plus 5. Negative 16 plus 7. And the answer is negative 9. Example 2. 2. Limit of x minus 1 over x squared plus 4 as x approaches to 2. Now substitute the value of x in the equation. We will have 2 minus 1 over 2 squared plus 4. And the final answer will be 1 over 8. 3. Limit of a sum or difference. Limit f of x plus or minus g of x equals. Limit f of x as x approaches to a plus or minus. Limit of g of x as x approaches to a. Example. Limit of x squared minus 3 as x approaches to negative 2. Limit of x squared as x approaches to negative 2. Minus limit of 3 as x approaches to negative 2. Equals to negative 2 squared minus 3. Equals to 4 minus 3. Final answer is equal to 1. Limit of 2x cubed plus x minus 4 as x approaches to 3. Limit of 2x cubed as x approaches to 3. Plus limit of x as x approaches to 3. Minus limit of 4 as x approaches to 3. Equals to 2. Multiply by 3 cubed plus 3 minus 4. And the final answer is equal to 53. Limit of a product. The limit of a product is equal to the product of their limits. Limit of f of x. Multiply by g of x as x approaches to a. Limit f of x as x approaches to a. Multiply by. Limit g of x as x approaches to a. Example. Limit 3x squared. Multiply by open and close parenthesis of to x minus 7 as x approaches to 4. Equals to limit 3x squared as x approaches to 4. Multiply by limit to x minus 7 as x approaches to 4. Now substitute the value of x, which is equal to 4. We will have equals to 3, multiply by 4 squared, multiply open and close bracket of 2 multiply by 4 minus 7, equals to 48 multiply by 1. And the final answer is 48. Limit of a quotient. The limit of a quotient is equal to the quotient of their limits, provided the limit of the denominator is not equal to 0. Limit f of x divided by g of x as x approaches to a. Equals to limit f of x as x approaches to a, divided by limit g of x as x approaches to a. Example. Limit x cubed minus 4 divided by 2x minus 1 as x approaches to 3 is equal to limit x cubed minus 4 as x approaches to 3 divided by limit to x minus 1 as x approaches to 3. Substituting the value of x equal to 3, we will have equals to 3 cubed minus 4 divided by 2 multiply by 3 minus 1 equals to 27 minus 4 divided by 6 minus 1. And the final answer is equal to 23 over 5. 6. Limit of a radical expression. The limit of the nth root of a function is equal to the nth root of the limit. Limit nth root of f of x as x approaches to a equals nth root of limit of f of x as x approaches to a. Example: limit of square root of 3x squared plus 4 as x approaches to negative 2 equals square root of limit 3x squared plus 4 as x approaches to negative 2 equals square root of 3 multiplied by negative 2 squared plus 4 equals square root of 16. And the final answer is 4. 7. Limit at infinity. The limit of c over x, or in general c over x to the n, where n is a positive integer as x approaches infinity, is 0. Limit of c over x to the n as x approaches infinity equals 0, where n is a positive integer. Example: limit 8 over x as x approaches infinity equals 0. Limit of 3 over x to the 4th power as x approaches infinity equals 0. Limit of 3x squared minus 5 over x squared plus x minus 6 as x approaches infinity equals limit of 3x squared over x squared minus 5 over x squared divided by x squared over x squared minus x over x squared plus 6 over x squared as x approaches infinity. Take note we divide by x squared each in order to satisfy the formula of limit c over x to the n power equals 0 as n is positive integer as x approaches infinity. Take note limit 5 over x squared as x approaches to infinity is equal to 0. Take note that 3x squared over x squared equals 3. Limit of 3 as x approaches to infinity equals 3. Remember property of limit number 1. X over x squared equals to 1 over x, and limit of 1 over x as x approaches to infinity is 0 as it satisfies property of limit number 7. Limit of 6 over x squared as x approaches to infinity equals 0 also satisfy the property of limit number 7. Therefore it will be equal to 0. Since x squared over x squared is equal to 1 and limit of 1 as x approaches to infinity satisfies the property of limit number 1. Therefore the answer will be 1. And our final answer will be 3.
Thank you for watching. Please subscribe to Marlin Technic TV.